Continuing on, we're going to be analyzing graphs of functions. There's going to be a lot of terminology in this particular section that you're going to have to know throughout the rest of the course. Domain, range, increasing, decreasing, minimum, maximum, what's meant by those. We'll start off with domain and range, and we'll start looking at some pictures and diving right in. Domain. Ask the question, what is x? Or what can x be? Or what is it for this particular function? The range. Ask the question, what are my y's? So let's go look at some graphs. I've graphed for you an absolute value function. The domain of this function, I look to see along the x-axis, what can x be? And now know that this equation is y equals the absolute value of x minus 1. X continues on in both directions, so it's going to keep on going off this screen. I just don't have a screen big enough to show how far it actually goes. So my x's are going to range from negative infinity to positive infinity. Remember, in the last section we talked about most of our functions are going to deal with earlier on in the course. The domain will be negative infinity to positive infinity unless it contains a square root or a denominator. Those are my main cases that I need to check. Now look at the picture and decide what the range is varying from. The range is up and down. Looks like it starts here at -1 and continues on up into infinity. There are some values. Now, does this include -1? I believe it does. So I'll use a square bracket, -1 on into infinity. And that's the domain and the range for the absolute value of x minus 1. Since I was talking about denominators, I thought I'd put you one up here that had a denominator to it. We discussed this one in the last video, and we said that x can be anything except for 2. I want you to look at this graph of this thing. Let's look along the x-axis. We have values for x all along through here, but when x gets to be 2, there's no actual line here. There's no dot or point where x is ever 2. But when I get really close to 2, I do have values. So the domain for this is x is a real number, or any real number. Probably should have said any. It's a real number where x is not equal to 2. That's my domain. Now, to get my range, I have to look at my graph. And it appears to me that I'm up here at infinity. That's okay. It doesn't look like it ever crosses this x-axis. So that must mean that y is never 0. But it gets really close to the x-axis, but I don't think it really ever touches. I think it just gets really close. So I can say that y is any real number where y is never equal to 0. Now there are different ways to write all of these things. This is just one of them. I'll show you a way that I could have written the range. I could have written the range as y is an element of the reals where y is not equal to 0. I could have also said, so this is one way to write it, could have also said y is anything from negative infinity up to 0, not including 0, union with 0 on up to infinity. And those roundy brackets right here tell me that it does not include that endpoint 0. We're going to look at this graph to do a number of things. We're going to look at it to calculate function values. if they ask you to find f of, let's say, 0. That means find this function value, or find y, when x is 0. So I go to where x is 0 and y there is 1. If they ask you to find f of, oh, I don't know, let's say 1, you say, what is y, or what is f of 1? That means what is y when x is 1. So I go to where x is 1, and I just read it off the graph. Looks like it's -2. This particular exercise is just to see if you can read the notation. It's not meant to be hard. It's just, can you read the graph? And can you read this notation? Remember, that's what's inside of here is what x is. Now, f of just means go find y. If they say f of x equals 0, that means go find x. Let me get rid of this little arrow here because it looks like it refers to that. Okay, so when y is 0, that would be right about here. What do you think? -1/2? So when x is -1/2, right here, looks like +1/2. Are these going to be exact? No, you can get those same things off your calculators, and he can give you just as good a guess as well. This one right here looks like, say, 1, 2, and maybe a 2 1/3. So we'll call that 7/3. In your calculator, you can ask it to find zeros for you, and the method for doing that depends on which calculator you're using. There are instructions in the TI-83 and the TI-84, I believe, in the I think it's course materials is what it's in. But you can look up the directions for how to do it with the TI. You can ask me how to do it. You'll just need to tell me what calculator you have. If you have a Casio or whatever, the steps are just going to be different. So I don't want to go through each of the individual steps here. All right. So that's finding function values. That's what that's about. In order to find where the function is increasing and decreasing and constant, I need to read the graph. I need to learn how to read the graph. I'm going to put the constant over here. We read our graphs from left to right. So I want you to look at this picture from left to right. So I'm going to read it going in this direction. So we're reading it like this. So as I go from left to right, I start to the leftmost point of the graph. And what am I doing? Looks like I'm increasing. So I would say that I'm increasing, and we write our description in terms of x from -infinity, because increasing are what the y's are doing, so I write where it's happening in terms of x. So it's increasing from -infinity all the way until I get up to when x is 0. So it's increasing from -infinity to 0. Now from 0 all the way up to when x is, man, that looks about like, oh, let's see, what do you think? We'll say 1.5. So 3/2. It's decreasing. Then when x is 3/2, all the way up to where x is infinity, going this way, it's increasing again. So I'll say it's increasing in this section or that section. So for 3/2 on up to infinity. And I don't have any constant sections in this graph. Constant sections look like this. They're just straight across lines where it doesn't go up and it doesn't go down, obviously. All right, might as well talk about minimums and maximums because I have a couple of them here. I have a maximum. There he is. The maximum is 1. right there. Now he's not an absolute maximum, meaning he's not the biggest maximum on the graph, but he is a maximum. We say that he's a relative maximum. He's a maximum relative to the points around him. So the maximum is 1 occurring, we'll say occurs, at x equal 0. Down here is my minimum, and he's a relative minimum. So we have a minimum is, so let's see, -1, 2, 3.5. So 3.5, we'll say that that is 7/2. Occurs at x equal, right there at 3/2, 1.5 again. And there would be some minimums and maximums. You're going to be answering the question, where is f of x, or where are your y's greater than 0? All that means is, where are they above the x-axis? Where are the y's greater than 0? Well, y is 0 right here, so anything above that would be where it is greater than 0. So from here to here, it is above the x-axis. So I would describe that by saying anytime x is in between -1/2 and +1/2. So anywhere in between -1/2 and +1/2. I'll write that interval notation for you. -1/2 and +1/2. Also, from here on up, it is greater than 0 all the way up. Okay, so that's about at 1, 2, what do you say, 2 1/3. So that'd be 7/3 from 7/3 on up. So I would describe that by saying anytime it is from 7/3 on up to infinity. So anytime x is 7/3 or 2 1/3 all the way up to infinity, it's greater than 0. So I have these two cases right here, and I'd probably put a union symbol in between them when I wrote them down. So my final answer, I guess I ought to write it in proper form, would look like this. Union with 7/3 on up to infinity. Another topic they're going to ask you to do in this section is to find the average rate of change. All they're asking you to do is find the slope. I know it looks scary, but all they really want you to do is find the slope. All right, so how do I find the slope? I need 2 points. I need y2 minus y1 over x2 minus x1. So I have the x values. That's nice. Now I just need to find the y values for each of those points. So f of 1, just plug these little guys in. Minus 2 times 1 plus 8. And this will get me 1 minus 2 is -1 plus 8 is 7. Then I need to find f of 5. And that would be 5 squared minus 2 times 5 plus 8. So 25 minus 10, that would be 15 plus 8, I believe, is 23. That's an ugly number. Okay, I'm just going to find the slope now. This is going to be my, I think this was x2, so this would be y2. This was x1, so that would be, whoops, y1. Okay, let's plug them on in, and then we'll be done. These are a lot easier than they look. So I'll have 23 minus 7 over 5 minus 1. And then I just do that little computation. 23 minus 7, I think that's 16 over 4. So this actually will end up being 4. And we're done with this one.